implementations. So I see I'm running out of time, so I'll do this very quickly and run a benchmark where we have this DGX A100 on which we're now connected to such a single Lightspeed enclosure, which happens to come with 4 servers inside it, right? Each delivering 100 gigabits per second. And we see that we're coming out north of 40 gigabytes per second, right? So that's the 400 gigabytes per second that we're really meeting at line speed of the Lightspeed enclosure here. So how is that possible? That's possible because in compliance with the NFS standard, oh, I need to move this a bit. We have extended the NFS implementation to actually support multipathing, right? So you're no longer limited to a single source and a single target interface. In fact, we're spreading the data here across all the interfaces of the DGX. And as a matter of fact, we're also doing the same on the server side, where this Lightspeed enclosure happens to come with 4 servers, as I said, right? And each of these 4 servers is contributing to the 40 gigabytes per second that we see, right? It's a bit off here, but you see that they are actually all delivering somewhat north of 10 gigabytes per second. So we've broken, right? We've broken that fundamental problem with NFS that it was assumed to be slow, where it's actually not slow, right? It all depends on the implementation that you have behind it. And the reason why this is possible is because we have that shared storage in the background, right? The NFS client does not even need to be aware of which server it is sending the data to, because all the servers are stateless and all the servers can give the same reply, right? So the NFS client can just send the requests round robin to any of the servers and will get the right answer from it. And we could take this even further, right? Here we were limited by the